Good morning, students. Welcome to science class on the chapter light. Today also we'll discuss one last problem of reflection part. Later, I will start refraction part. Okay. See the last problem. When an object is placed at a distance of 60 centimeter from a diverging spherical mirror. Okay. What is that? Diverging spherical mirror. The magnification produced is 0.5. The magnification produced is 0.5. Where should the object be placed to get a magnification of 1 by 3? Okay, see here, just imagine here the see it is a diverging mirror, right? Diverging mirror means that is convex mirrors. Okay, converging mirror means that is concave. Okay. Now, just imagine at some point now the object is placed. Okay, the distance between the object and the mirror is say 60 centimeter. Okay, and here you are getting just when the magnification is 0.5. So now here in this question we need the magnification 1 by 3. When you keep the object at 60 centimeter from the mirror, then you will get the magnification 0.5. Now I need the magnification 1 by 3. Then where should the object be placed? Okay. See here, here we don't know what is focal length of the mirror and image distance, nothing, right? Okay. See here we know the object distance. Okay. When you know the magnification 0.5 for magnification 1 by 3, here also we don't know where we should keep that object. So our work is to find out where should the object be placed. Okay. See here. First write the object distance. So u is equals to minus 60 centimeter and the magnification is clearly we can write 0. Plus 0.5. Why? Because it is a convex mirror or diverging spherical mirror. Okay. Next, how to find out? See, observe here. Here in the first case we will get the magnification 0.5. In the second case the magnification is 1 by 3. In the first case object distance and image distance are different for when you get the magnification 1 by 3. Okay, but in both the cases one thing is same. What is that? That is focal length. Okay, see you can change the object position and see if you change the object distance then the image distance also changes, but focal length it remains same. Okay, first find the focal length of the mirror. See here we know m is equals to minus v by u. What is the magnification? Magnification is 0.5 minus v by u. U means that is minus 60. Minus by minus plus. So we can write this as 0.5 equal to v by 60. Okay. Then we can write this as v equal to 0.5 into 60. Okay. For example, we can write this as 1 by 2 into 60 also. 1s are 60, 30 are. Okay. So v equal to 30 centimeter. Okay. So the object is placed at a distance of 60 centimeter and the magnification is produced. Then the image distance is 30 centimeter. Okay. See, this is for first case. Okay. So now we can find out the focal length, right? So now we can find the focal length. So V is equals to 30 centimeter. Okay. Next, we know the formula. 1 by f is equals to 1 by v plus 1 by u. Okay. 1 by f equal to 1 by v is 30, then plus 1 by v is minus 60. Okay, plus or minus minus, that is 1 by f 1 by 30 minus 1 by 60. Okay. Next, 1 by f equal to, see the LCM of 30 and 60 is, that is 30. Okay. So now here you have to multiply 2 and here 1. This 2 minus 1. Here, next one, that is 1 by r equal to 1 by 60. Then f equal to 60 centimeter. Okay. So now the focal length of that diverging spherical mirror, that is 60 centimeter. Okay. Yes. So next, where should the object be placed to get a magnification of 1 by 3? In this case, we don't know object distance, we don't know image distance. Okay, see this minus 60 plus 30 for this one when the magnification is 0.5. Okay, now here the magnification changes. When the magnification changes, when it changes when you change the position of the object. If you change the position of the object, then automatically we can say that the image distance also changes, or position of the image also changes. Okay. Yes. Now how to find out the object distance? So now magnification equal to 1 by 3. Okay. Then focal length, right? Focal length equal to 60 centimeter. Okay. Next, how to find out? So here we need u, right? Here we need u. We know the formula 1 by f equal to 1 by v plus 1 by u. If you want to calculate u, you should know focal length and image distance. Here you know the focal length, but you don't know image distance, right? How to find out? See, just use this one. Okay, magnification equal to minus v by u. We can write it as 1 by 3 equal to minus v by u. Okay, so now bring u this side, that is u by 3 equal to minus v, or we can write v is equal to minus u by 3. We can write like this, right? Okay, so v equal to minus u by 3. So now substitute in this equation. So 1 by f means that is 60 equal to 1 by v equal to what? Minus u by 3 plus 1 by u. So now this 3 goes to upper side, right? And here plus by minus minus, that is 1 by 60 equal to minus 3 by u plus 1 by u. 1 by 60 equal to minus 3 by u plus 1 by u. Okay. Next, 1 by 60 is equals to LCM. So now LCM is q, right? U minus 3 plus 1. What is the answer? 1 by 60 equal to minus 2 divided by u. Okay. So now bring 60 this side, u this side. That is u is equals to 60 into minus 2. Okay. Next. So u is equals to minus 120 centimeter. So u is equals to minus 120 centimeter. Okay. See here, if you want to get magnification 1 by 3, then you should keep that object at a distance 120 centimeter from the mirror. Okay. Here, if this is a mirror, then the distance between object and the mirror, that is a convex mirror, the distance it should be 120 centimeter. Then you will get the magnification 1 by 3. Okay, so lengthy problem. I think it is not that much difficult. Okay, yes. Next, move to reflection part. Yes. Next, move to reflection of light. Okay. Till now you have studied what when you keep the opaque objects in front of a light, then it undergoes a reflection, right? For example, here light is passing. If you keep an object here, then light it undergoes reflection. Okay. So now instead of opaque objects, so you will keep some transparent things. For example, here the light is passing here. I am passing light here. Then I will keep one what glass here. At that time, what will happen? Do you think that here the light it undergoes a reflection? Yes. No, right? Here light while traveling through glass. So now here light is passing, right? So I am keeping one glass here. So in this case, light it bends. Okay, light it bends. You know, you have seen some optical phenomenon. For example, when you immerse a pencil in a water, it looks like a bent, right? Little bit. You know, a water tank. The bottom of that water tank it appears to be raised. Then the bottom of the swimming pool it appears to be raised. Okay, but when you remove that pencil from that water, then it's a size or shape as it is, right? When you immerse that pencil in a water, then it appears to be what it bend, it will bend. When you remove it as it is, why does it happen? And you know, when you put the one lemon in a glass tumbler, okay, you can see the enlarged image of that lemon, means bigger the lemon. If the size of the lemon, if it is like this, when you put in that glass, then its size looks like this. Okay, what are the reason for these things? Okay, yes, tell what are the reasons? So that is due to the refraction of light. You know, when you put a water drop over the letters, okay, then those letters, that letter appears to be a little bit raised, right? Okay, when you keep the glass over the letters, then the letters are appears to be raised. Okay, see, for this optical phenomenon, that is due to the refraction of light. Okay, then what is the refraction of light? Refraction of light means the ray of light while traveling from one medium to another medium, it bends. Okay, the bending of light while traveling from one medium to another medium is known as refraction of light. Okay, the bending of light while traveling from one medium to another medium is known as refraction of light. Then see, here I have used in the definition of the refraction of light, I have used medium. Okay, what is that? See here, medium in, for example, you know, air. Okay, take air and water. The arrangement of particles in air and water both are different. Okay, so now I will call air is one medium and water is another medium. Okay, so we can differentiate water, glass, air, then others, for example, turpentine, petrol, diesel. Okay, in these mediums, the arrangement of particles are different. So that's why we can differentiate. This is air medium, this is water medium, this is glass medium. So like that. So clear, right? What is medium? Okay, so medium is for air. Like the particles are loosely, freely arranged. Okay, so we call it as this is one medium. Then if you take the water, in water electrons are loosely arranged. We'll consider water is one medium. Then if you take glass, in a glass all the particles are tightly arranged. Okay, then we consider glass is another medium. Okay, so refraction of light means the bending of light while traveling from one medium to another medium. Okay, so this is known as refraction of light. Okay, so now the pencil immersed in the water. Just imagine this is a pencil. See, when you put the water, then this pencil, it looks like this. It looks like this, little bit bent, right? So why? What is the reason? Yes, the reason is the refraction of light. But how? The speed of light, that is c equal to 3 into 10 raised to the power 8 meter per second. This is the speed of light in vacuum. Okay, the speed of light in vacuum is 3 into 10 raised to the power 8 meter per second. In air medium also we will take, so that is approximately equal to 2.98 something. So but while calculating, so in air medium also we will consider the speed of light as 3 into 10 raised to the power 8 meter per second. Okay, see here. We can see the things because of reflection of light. See, now I am able to see this board. Why? The light rays first falls on the board, then those rays are reflect to my eyes. Then I am able to see the board. Okay. So now here you are observing from here. Okay. Just imagine you are observing from here. You are observing here. Okay. So now the light rays. Okay. The light rays should come from first water medium, then air medium. Okay, see now this portion, it looks like a bend, right? Why? Because here the rays are from this portion. They should travel first water medium, then air medium. Okay, so now here light is traveling first water medium, then air medium. Okay, I told what is refraction of light. Refraction of light means the bending of light while traveling from one medium to another medium. Here the rays are traveling from water medium to air medium. Here the medium changes, right? So that's why this pencil, it looks like a bend. Okay, clear? Just imagine. Take one ball. Okay, just imagine you are standing here. Okay, just imagine you are standing here. So here we'll keep one coin, 5 rupees coin. Okay, so now here we have to stand like this. Okay, for example, see here. If you come 1 centimeter or 2 centimeter little bit forward, then you are able to see that coin. If you go back if you go 2 centimeter back, then you are not able to see that coin. You have to stand like so, like that. Okay, so then see, just imagine you are standing here. Now you are not able to see the coin. Okay, see, if you come 1 centimeter forward, then you can see the coin. So now just imagine you are not able to see this coin. So just tell your friend to pour the water. So then you can see the coin. Okay, why? Because here the rays, okay, the rays should come from water medium to air medium. They should travel first water medium, then air medium. Okay, so that's why while coming from one water medium to air medium, the rays bends. So that's why that coin it appears to be raised. Okay, so I will show you the diagram. Okay, here the coin is placed. Okay, so it is filled with water. So just imagine now I'll take two rays. See here the rays are bends. Okay, see just observe here. So now the rays are traveling from air medium to water medium. The rays bends, right? Just observe here. If we extend these lines in a straight path, see both the rays are meeting at this point. So now this coin it appears to be raised here. Clear? Okay. See if you extend these straight lines. Okay. So now for your eyes the rays are coming from this point. So now at this point that coin is appears to be raised. So this is the reason. Okay. Why the coin when you pour the water why it is appears to be raised. Okay. So this is due to the refraction of light. Hope you got the reason why it is like that. Okay. Yes. In your swimming pool also what that bottom of that swimming pool it appears to be raised. Here also the rays should travel through first water then air medium. Okay, the rays should come from water air medium. So while coming from water to air the rays bends. So that's why the bottom of the swimming pool it appears to be raised. Even the same reason for the water tank, that bottom of that tank appears to be raised, right? Okay, then when you keep the lemon in a glass tumbler, it's you can see the enlarged image of that lemon. Okay, so for all the things the refraction of light is a reason. Okay, yes. So next move to refraction through a rectangular glass slab. Okay, rectangular glass slab. When a wave ray travels from one medium to another medium, it bends. Why it bends? Why it bends? The speed of light in a vacuum, that is c equal to 3 into 10 raised to the power 8 meter per second. Do you think that light will possess the same speed in air medium, or when you pass that light through water medium or petrol, diesel? Do you think that the speed of light remains the same? No, the speed of light changes when traveling from one medium to another medium. So that's the reason why the light rays bends. Okay, clear? So while traveling from one medium to another medium, the light ray bends. It is due to the change in the speed of light. Okay, for example, the speed of light in vacuum is different, the speed of light in a glass is different, the speed of light in air is different. Why? Because the arrangement of particles are different in all the mediums. Okay, for example, if you pass the rays of light in water, at that time the speed of light decreases. Why? Because in water that light will get more disturbance. If you pass that light in a glass, there also the disturbance is increases. So that's why it bends. Okay, so why the rays bends means that is there is a changes in the speed of light. Clear? So next we move to refraction of light through a rectangular glass slab. Just imagine this is one rectangular glass slab. This is one rectangular glass slab. Okay. So now I am passing ray of light. I am passing ray of light. So okay. Just I am passing only one ray. Okay. Next. This is we call it as an incident ray. At the point of incidence, now this incident ray strikes the here, right? At the point of incidence, we will draw one line perpendicular to that surface, okay. And already we are studying the in the reflection part, right? So we call it as normal. Here also we should draw normal at the point of incidence, and it should be perpendicular to the surface, okay. Now see, now that light ray entering to the glass, right? But how it bends? Whether it bends see here, see whether it bends like this or like this or like this, okay. See, if it bends like this, then we call it as a reflection of light. It is impossible because it is a transparent, okay. It should bend like this or like this or like this, okay. So now how it bends, so I am passing a ray of light from air medium to water medium, air medium to water medium, okay. So here, the while traveling from air to water, the speed of light increases or decreases. In air medium the disturbance is less, but in water medium little bit the disturbance is more for that speed of light. So here in water the speed of light decreases, its speed decreases, okay. So then it bends towards the normal, normal. Why? Because its speed decreases, okay. Now because our ray of light traveling from air medium to water medium, see this is the actual path, right? If you won't keep this glass there, then it will move like this in a straight line. See here, you have kept the glass, so that's why that light ray bends. How it bends? It bends towards the normal. Why it bends towards the normal? Because of the speed of light decreases. In air medium, speed of light is more compared to the speed of light in water medium. Okay, so here while entering to water medium, its speed of light decreases, so that's why it bends towards the normal. Okay, yes. Next one. See here. So now here the speed of light is more and here the speed of light is less. So now we can call this A as optically rarer medium. What is that? Optically rarer medium. Optically rarer medium, because here the speed of light is more compared to this one, right? Next we will call optically denser medium. Optically denser medium, okay. For example, I will give you two mediums, X and Y. So now I'll say that the speed of light in Y medium is more than speed of light in X medium. So then we can say that clearly this Y medium is optically rarer medium and the X medium is optically denser medium. Okay, see, every time we won't call it as optically denser medium, just we use a rarer medium and denser medium. Okay, so out of these two mediums, the speed of light is more in air, right? So that's why we call air medium as rarer medium and water medium as denser medium, because it is this. Sorry, this is glass, right? Sorry, extremely sorry. Okay, this is a glass. Okay, no problem. Because the glass is more denser than air medium. Okay, so that's why we will call this glass as denser medium and this air as optically rarer medium. Okay, why? Because see, why we call this as the optical density of air is greater than optical density of glass. Okay, we'll study in higher classes what is optical density. Okay, why? Because see here the number of electrons are very less here, but number of electrons are here more. So that's why the speed of light decreases here. So that's why we call it, this is a denser medium and this is rarer medium. Okay, so listen here. Here now I have passed a ray of light from air medium to glass medium, that is rarer medium to denser medium. Here that light ray it bends towards the normal. Okay, now what happens, suppose if I pass the ray of light from glass medium to air medium or denser medium to rarer medium, how it bends? Okay, see here, this is glass. I am passing a ray of light from glass medium. Incident ray, normal. Okay. So now our ray of, this is a glass medium and this is water medium, or we can say this is a denser medium and this is rarer medium. Rarer medium. So now in the first case here, while traveling from rarer to denser, its speed of light decreases. So that's why it bends towards the normal. So now in this case, our ray of light traveling from a denser medium to rarer medium. Okay, how it bends? So now in this case, here the speed of light increases, right? Why? Because it is traveling to air medium. Here the distance is very less. So here the speed of light is increases. So that's why it bends away from the normal. It bends away from the normal. Okay. So while traveling from rarer medium to denser medium, the ray of light it bends towards the normal. But while traveling a ray of light from denser medium to rarer medium, at that time the ray of light bends away from the normal. Why here speed of light it bends towards the normal? Because here the speed of light decreases, but in this case the speed of light increases. So that's why it bends away from the normal, and here it bends towards the normal. So clearly got why it bends towards the normal and away from the normal. Okay. Yes. Now just imagine I am passing a ray of light from water to glass. Water to glass. What now? This is water and this is glass. So now here, out of these two, which one is rarer and which one is denser? Okay. So here in water medium, speed of light is more than speed of light in glass medium. So clearly we can say that water medium is a rarer medium and glass medium is denser medium. Okay. Now I am passing a ray of light from rarer medium to denser medium. So now how it bends? I am passing ray of light from rarer to denser. So then its speed of light decreases. So that's why it bends towards the normal. Okay, it bends towards the normal. Why? Because here the speed of light decreases. Why? Because we are passing a ray of light from denser medium to rarer medium. Okay, in the speed of light in a glass medium is less. The speed of light in glass medium is less compared to speed of light in rarer medium. Suppose I pass a ray of light from glass to water, means denser medium to rarer medium. So I am passing ray of light from denser medium to rarer medium. So now its speed of light increases. Its speed of light increases. It bends away from the normal. It bends away from the normal. Okay. So clear what is the refraction of light, and also studied the reasons for optical phenomenon, and you studied what is rarer medium, denser medium, how it bends, whether it bends towards the normal or away from the normal. Okay. So next move to laws of the refraction of light. We have studied, right, in the reflection of light. We have studied two laws. Angle of incidence is equal to the angle of reflection. Then what second one, incident ray, normal and reflected ray all lie in the same plane. Here also we are going to study two laws. Okay. See here. So now we call this as incident ray because the ray is coming from the source, right? And this as refracted ray, not reflected ray. What is that? Refracted ray. Refracted ray. Okay. And see here, the angle between incident ray and normal is known as angle of incidence. We use a small x at present. Okay. Next, the angle between normal and refracted ray. Okay, the angle between normal and refracted ray is known as angle of reflection. Sorry, angle of refraction. Is that the angle between normal and refracted ray is known as angle of refraction. Don't confuse with angle of reflection. Okay. So now to represent an angle of reflection, we use a small r only. Okay, in a reflection part, so r means angle of reflection. In a refraction part, small r means angle of refraction. Okay, the first law of refraction of light, which says that in the reflection light. Is a mirror, incident ray, reflected ray, normal. In a reflection part, angle of incidence is equal to angle of reflection. Do you think that here also angle of incidence is equal to angle of refraction? If it is same, then there is no bending of light. Correct? Okay. So here the ray bends. So clearly we can say that angle of incidence is not equal to angle of refraction. Okay. Yes. So first law of refraction of light, it says that incident ray, normal and refracted ray all lie in the same plane, similar to second law of reflection of light. Okay. For example, just imagine this here one glass is there. I am passing light here and it bends here. So now incident ray, this normal and refracted ray all lie on the same plane, right? Okay, so that's why refraction of light, the first light states that incident ray, normal and refracted ray all lie in the same plane. Okay, next, second law. What is the second law? Second law, it states that the ratio of sine of angle of incidence to the sine of angle of refraction is constant for a given pair of mediums. So that is, you can write sin I divided by sin R equal to constant. Okay, so what is the second law of refraction of light? The ratio between sine of angle of incidence to the sine of angle of refraction is constant for a given two pair of medium. Okay, then what is the meaning? Sin I by sin R equal to constant. Okay, now see. Here you should know trigonometry because we are using trigonometric functions, that is a sine. Okay, just imagine this is one glass. Okay, incident ray. This is I, this is R. Okay, so now just imagine. Here, just imagine, I'm not taking the exact value. I take the angle of incidence is 30 degree. I equal to 30 degree. Then angle of refraction is say 26 degree. See, I'm taking just roughly. Okay, these are not exact values. So first I am passing a ray of light at 30 degree. Then the angle of refraction is 20 degree. Then you have to take the ratio of these two. That is sin I divided by sin R. Okay, so here you have to here you have to find sin I means what? 30. Here you should write sin 30. Then here sin 26. Okay, so here you will get one value sin 30, okay, and sin 26. Okay, so you know sin 30, sin 45, sin 60, there are so many values are there. Okay, you studying in your mathematics. Okay, in the chapter trigonometry. Now here you should write sin 30, that value here, then sin 26. Sin 26 you should write here, then you have to divide both. So here you will get one answer. Just you will get one answer. Next, in the second case, okay, in the second case, I will change the angle of incidence. For example, say I will pass say that is angle of incidence is 40 degree. Then angle of refraction is 35 degree. Okay, so once again here also same. You have to take sin I divided by sin R equal to sin 40 degree divided by sin 30 degree. Here also you will get one value. Okay, sin 40 you have to write the value here, sin 30 degree you have to write here. Okay, sin 35. Okay, so you have to write here. So I am dividing, here also you will get one answer. Okay. Next, see, you can't write directly. If you know the angle of incidence, you can't write angle of refraction directly. That has 35. You have to measure. First, you have to take one rectangle glass slab. You have to pass that ray of light at what degree you are passing. Then you have to note down the refracted ray. You have to draw a number. Then you have to measure the angle. You have to do everything practically. See, just I am without the practical. Just I am writing roughly. Okay. Next. I'll take one. I'll change the angle of incidence. Say I am passing a ray of light at 55 degree. Then angle of refraction is 50 degree. Okay. So now here I equal to 55 and R equal to say 51. Okay. 51. Next, once again, sin R equal to sin 55 divided by sin 51. Then here you will get two values. So if you divide these two, then you will get one answer. Okay. See here I have changed the angle of incidence, means I have passed at a different angles, and here I am not changing the source of light. See here what we are using that source of light, we have to use the source of light same for all in all the cases. Then here you have to use one glass, you have to use the same type of glass here and here. You know, in glasses there are different types of there. Okay, chrome glass, etc. Okay, next here you have to use the source of light same, then you have to use the glass material same in all the cases. Okay, while dividing here, just imagine you will get say 1.5. Here you get 1.5, right? Then here also you will get 1.5. Then here also you will get 1.5 only. Okay, that means if you pass a ray of light at a different angle, whatever it be, okay, while taking the ratio sin I to the sin r, you will get the same answer for all the cases. So this is the second law of refraction of light. What is, see here you have to use the same mediums. Here you are using the air and water. If you, air and glass. If you use air and water, then you will get the different answer. Okay, here you have to use the same mediums and same source of light. You know, in light also different types are there, right? If you use a red light, and if here use a white light, if you use your yellow light, then the values are changes. Okay, here you have to use same source of light and same mediums. If you pass the rays of light at a different angles, okay, but at last finally while taking sin I by sin r, when you do this one, you will get the same for all the cases. Suppose if you get here 1.6, then you will get 1.6 only. Here also 1.6 only. Okay, so this is the second law of refraction of light. Means, see, it's very simple. If you pass a ray of light at a different angle, if the angle of incidence is different, then angle of refraction is also different. But finally, if you take the ratio sin I to the sin r, then you will get the same answer for all the angles. Okay, so this is the second law of refraction of light. Okay, what it says that the ratio between sine of angle of incidence to the sine of angle of refraction is constant. Why it is constant? Because here we got 1.5, here also we got 1.5, here also 1.5. So it's a constant, right? Same value, right? So that's why the second law we can write sin I divided by sin r equal to constant. Okay, yes, so this constant is known as refractive index. Okay, so one more important physical quantity we'll study in the next class. What is that? Sin I by sin r equal to constant. This is the second law of refraction of light. This constant is known as refraction of light. Okay, so now here while doing here you got 1.5, right? So this 1.5 is the refractive index of this medium with respect to this one. So now I will call this is medium 1 and medium 2. Now you are passing a ray of light from medium 1 to medium 2, right? You are passing a ray of light medium 1 to medium 2. So you will do these things, then finally you will get 1.5. Just imagine. Okay, then this 1.5 is the refractive index of medium 2 with respect to medium 1. Okay, for example, just imagine I am passing a ray of light from water to glass. So here also if you take sin I divided by Sin r, here you will get one answer, right? Then see, now this is medium 1 and medium 2. Now I am passing a ray of light from medium 1 to medium 2. So now you will get one value, right here. So this value is the refract index of the second medium with respect to medium 1 or medium first. Okay, we'll discuss tomorrow clearly what is a refractive index. Okay, and see this expression sin I by sin r equal to, so we call this as Snell's law. What is that? Snell's law. Okay. So clear, right? See, we call this law as Snell's law. Sin I by sin r equal to constant. Okay. So maybe in your exam they will ask write the Snell's law. So then you have to write second law of refraction of light. Okay. And last thing, just imagine here. So this is R. This is rarer medium. This is denser medium. Okay. Now, see, I am passing a ray of light from rarer medium to denser medium. So here speed of light, so that's why it bends towards the normal. In this case, angle of incidence is greater than the angle of refraction. Okay, when you pass a ray of light from rarer medium to denser medium. Okay, when you pass a ray of light from rarer medium to denser medium, at that time angle of incidence is greater than angle of refraction. Suppose if you pass a rays of light if you pass a ray of light from denser to rarer, so in this case the speed of light increases, so that's why it bends away from the normal. So here we are passing ray of light from denser to rarer, its speed decreases. In this case, angle of incidence is less than angle of refraction. Okay. So when you pass a ray of light from rarer medium to denser medium, here angle of incidence is greater than the angle of refraction. But from denser medium to rarer medium, here angle of incidence is less than angle of refraction. Okay. So I will give you one homework. If you pass a ray of light perpendicular to the surface, how it bends. Okay, we will discuss tomorrow. I will stop here.